Hi everyone, welcome to the Microsoft series day 3. So before starting with the problem, I will say that if you haven't registered for the Microsoft in 29 days course, so you can find the link of the course in the description of this video, and if you will click on the description link, so you will be redirected to this site, and in this site you will have Microsoft in 29 days self-paced course. And once you register for the course and you click on the start course, so you will get very easy access to all the problems. Like if I click on day 1 here, so you will be able to observe that if I click on day 1, so I'll be redirected to the site where I can have the access to the individual problems of day 1 and day 2 one by one. And after that, if I see here the problems that we give, like on every day we give 5 problems, where total 2 problems are solved and 3 problems for homework. So you can see that along with the company tag and everything, the problems are given. Like you can see for key pair we have mentioned all the companies. For 3 sum, for finding all 4 sum numbers, we have mentioned the company tags for the problems as well. So in this way you can practice. Apart from this, you will get the leaderboard and many other exclusive things. So make sure to register for it if you haven't. Now let us discuss the problem, that is count sort. So in this problem, what we will be given is, we'll be given an array of integers and we need to find the count of inversions in the given array. Now what do we mean by inversions? Okay, so if we talk about an array, let's say we talk about an array which is something like this. Let's say the array is 3 and then it is like 1 and 2. Okay, suppose this is the array. So basically what is the inversion? So like the one inversion is said to be done when an element ai and aj are there, and like suppose there are two elements, right? There is an ith element ai and there is a jth element aj. So if it happens that AI is greater than AJ, okay, if AI is greater than AJ and I is lesser than J, okay, whenever it happens that AI becomes greater than AJ, okay, whenever AI becomes greater than AJ and I is lesser than J, in that case we say that one inversion has happened. So let us try and see for this case. When I'm at this 3, so I can see that I can see that 3 is greater than 1, okay, and the index is lesser. So that means I'll count it as an inversion. Then I can see here as well that 3 and 2, like 3 is greater than 2 as well. So that, and the index of 3 is lesser than the index of 2. So I'll count it as one more inversion. Then what will happen? I'll move here, and I can see that 1 and 2, between 1 and 2 there is no inversion because 1 is lesser than 2. So the total number of inversions for this answer will be 2. Now let us discuss another case so that we can understand things better. Suppose that we have been given what? We have been given 4, 3, 2 and 1. If we have been given this example. So in this case, you will observe that for 4, it is greater than all the 3 elements, right? It is greater than 3, it is greater than 2, it is greater than 1. So the inversions that 4 will have is 3. Total number of inversions that 4 will have is 3 because it is greater than 3 elements. Then if you see 3, so 3 is greater than 2 as well as 1. So that means 3 is having 2 inversions. 3, like 4 is having inversion with 3, 4 is having inversion with 2, 4 is having inversion with 1 as well. 3 is having inversion with 2, 3 is having inversion with 1, then 2 is having inversion with 1, right? So you can easily observe, right? After this, like you can say that 2 is having inversion with 1. So total 1, right? So total 6 inversions you can observe that are happening. Basically, what is happening? If you see, 4 is having inversion with 3 because 4 is greater than 3, 4 is greater than 2, 4 is greater than 1, then 3 is greater than 2, 3 is greater than 1, and then 2 is greater than 1. So these are the inversions that we are having. Now, like one of the brute force way to do this thing would be that what I can think of is, I can say that I want, if I am at the ith element, so I want a j element says that I is always lesser than j. Okay, like look at the constraints. The constraint is that ai should be greater than aj and I should lie towards the left side of j. This should be the constraint. So for this, what I can say is, I can simply say that I can run a loop. I starts from 0, I is lesser than n, and then I plus plus. Okay, and then what I can think of doing is, I can say that for int j starts from I plus 1, j is lesser than n, so that j is always greater than I, and then j plus plus. And then what I can say is that if it happens that a of like a of I, if a of I is greater than a of j, then what I do is I count it as an inversion. So I say that inversion plus plus. So basically I count it as an inversion, and by doing this, what will happen? If I do this, then this loop takes order of n time. Inside it there is another loop which takes order of n time. So overall order of n square approach will be taken, and this is very costly. So can we do something better than this? Yes. Basically, if you will observe, so we are trying to do what? We are trying to count the inversions. That is the number of elements, right? So what we can do is we can apply the merge sort algorithm here. Okay. So the prerequisite for this problem is merge sort algorithm. And with the merge sort algorithm, with the help of the merge sort algorithm, what we can do is we can simply find out the answer in optimal manner. With merge sort algorithm, the time complexity for finding the number of inversions will be order of n log n. How? Let us try and understand. So let us say that if we have been given a particular uh, array, like suppose that we have been given 6, then we have been given 3, then we have been given 9, then we have been given 5, then we have been given 2, 8, 7 and 1. If this has been given, so if we break it into two parts as we do in merge sort, so this will be what 6 9 6 3 9 5, and this will be 2 8 7 1. Okay. Then if I break it further into two parts, so this will be 63, this will be 95, then this will be what 28, this will be what 71. Now you'll say what I am trying to do. Am I trying to do merge sort? No, basically I'm trying to do merge sort, but with the help of merge sort, I'll try to calculate the answer. Then this will be 6, this will be 3, this will be 9, this will be 5, this will be 2, this will be 8. Here you can see 7 and then 1. Okay. Now comes the merging part. Okay. Now you see that if this much part has been done, now we will focus on the merging part. Like what happens when I merge. So while I am merging, so that's where the magic happens. Because if you see here, like this element, if you see this element 6, if you see this element 6, this element 3, so basically what is happening here? Here you can see that this element is what? This element is lying towards the left side. Okay, you can see here, right? 6 is lying towards the left side of 3. So that means while you're merging it, you can see that 6 is lying towards the left side of 3, and 6 is what? 6 is greater than 3. That means this will be counted as one of the inversions, right? Similarly, here you can see that 9 and 5 will be counted as one of the inversions. You'll say, okay, that's fine. Okay, then you can see here no inversion will take place. Here also inversion will take place because 7 is lying towards the left side of 1. Then what happens? Then after that, after you merge this part, so after you merge these two, so it becomes 3 6 here, and then this becomes 5 and 9 here, right? And here it becomes 2 and 8. Okay, and here this becomes 7, like 1 and 7. Okay, after this part, like you will be able to observe, like while I merge these two, like basically this is separated with commas. The elements are separated with commas as always. So what will happen here is, if I have these elements, so in this also I can try to see, like 6 is there, right? You can see 6 is there, and like if you see 6 and 5, so this can be one of the inversions as well. So let us move to the next step and try to merge this up. So if we try to merge this, so what will happen? This will be 3 5 6 and 9, and like if I have merged these two and if I have merged these two, so this is separated with commas. You can understand that this is 1 2 7 and 8 here. So now let us try and focus on this step. So I'll try to highlight this point here so that you can understand better. So if I have 3 6, okay, and then I have 5 and then 9, and I have here what? I have 1 then 2 then 8, like then 7 and then 8. So while I am performing the merging operation, right? So the thing is how to count the number of inversions, right? How to count the number of inversions. So basically some of the inversions, like this left part, right? There is a left part, there is a right part, this is the left part. So the left part, like when I get the left part after merging, so that will give me some number of inversions, right? So I'll say that some number of inversions I'll get from the left part, some number of inversions I'll get from the right part. And when I merge these two arrays, right, then also I'll get some inversion. Why? Because if you see here, so basically some of the inversions I'll get from the left part, because while I merge this part, while I merge this, so I must have got some inversions, right? I must have got some count of inversions. Here also similarly, when I merge this array, so must have got some inversions. And after that, while I'm merging these two also, I'll get some, because if you see 1, right, if you see here 1 and if you see here 3, so this element, right, is what, like I always need to find a of I, says that a of I is greater than a of j. Okay, and a of I is greater than a of I should be greater than a of j. This is one of the things, and I should be lesser than j. So you can observe easily that this one is lesser than this 3. Perfect. This one is lesser than this 6, this one is lesser than this 5 as well, this one is lesser than this 9 as well. So that means I'll count all the inversions. So basically this element 1, like here, that is the beauty of merge sort. That merge sort, like while I'm at this index only, then if this ith index, right, if I am this as I and this as j, so I can say that this total length of the array minus I, like basically I'll say that the number of elements that are there, so total 4 elements are there, so one will have inversion with 4 elements, and I'll count it once only, right, while doing the merge operations. Because as you know, like this much till this much part, like this array is sorted. So basically if this ith element is greater than the jth element, so that means all the elements towards the right side are also greater. So I'll count them, right? I'll count them. I'll show you in the code like how we'll be counting this part. And then what will happen? Like similarly, when you move to 2, so you see that you see that this 3 is greater, right? Similarly, all the others are greater, right? Then what happens? Then if you move to 7, so 7 is having inversion with 9, you can observe, right? After this part, if you move to let's say 8, so if you move to 8, 8 is having inversion with 9. So that's how you are counting the inversions. Like some part you will be getting some inversion from the left part, okay? Some inversion from the left part, some inversions from the right part, okay? From the right array, from the left array, from the right array, and some inversions while merging, right? While you merge. So this is what will happen. Let us try and have a look at the code, like how we'll actually be doing it. So first of all, what we'll be doing is we'll be given the array, right? We'll be given the array in which we have to count the inversions, and here we'll be given the array and the size of the array. So we will first of all perform the merge sort operation starting from the 0th index till n minus 1. The reason why I'm not writing code and focusing more on the logic is so that you can understand things much better. So I'll have the inversion count as 0. Then if my L is lesser than R, if I'm L is lesser than R, so if I'm in this range, so in that case, first of all I calculate the mid, because I have to perform the like I have to divide the array into two parts, right? That is what I first of all do. I first of all divide the array into two parts, then after that I merge them, right? So inversion, like I'll get some number of inversions from the left part of the array, that is starting from the index L till mid. That is nothing but some of number of inversions I'll get from the left part, as I mentioned, while I'm performing the merge sort, and some number of inversions is what I'll get from the right part as well, right? After this, after I'm merging, so I'll get some number of inversions from the merging of this array starting from L, and which is having mid and R as the last index, okay? So what I will be doing in the merge function, I'll tell you. The main thing is happening in the merge function only. So what we'll be doing in the merge function is I'm taking long here. So n1 is there, right? So n1 is the size of the first array. So size of the first array will be nothing but mid minus L plus 1, because if an array is starting at L, okay, if I'll tell you, if suppose that the first array is starting at L and ending suppose that it is ending in mid. So like right, if j minus I plus 1, if j is here and I is here, okay, so the length of the array is what? The length of the array is j minus I plus 1. Similarly, mid minus L plus 1 will be the length of the array. And what I will do is I will have the second array as well, and I'll have the length of the second array as well. That will be nothing but r minus mid. After that, I'll declare two temporary arrays for performing the merge sort operation. So I'll store first array and the second array, like first half and the second half. After that, I'll perform the merge sort operation, and if it happens, like I will perform it until I is lesser than the size of the first array and j is lesser than the size of the second array. If it happens that the ith element is lesser than the jth element, then that's perfectly fine, and I'll simply perform the merge sort. Otherwise, if it happens that the if the ith element is greater than the jth element, okay, so that I is lesser than j and a of I is greater than a of j. So that means this is the condition for inversions, and in that case, at one point of time only, I'll calculate all the elements, right? As I mentioned, because as I mentioned here, if I was having 3, 5, 6, and 9, and if I was having 1, 2, 7, and 8, okay. So if I was here at this, like if my j was here and if my I was here, and if I know the size of this array, suppose as n1, so that means how many elements will be there? Like n1 minus I, okay. So that are going to be the elements. So basically, because this one will make inversion with this 3, with this 5, with this 6, and with this 9. So I'll count all of them at once. That's why the time complexity using merge sort will reduce. And after that, if some of the elements are left in the first array, then I'll add them up into while merging. And if the sum of the elements are left in the second array, then I'll add them up and I'll simply return the number of inversions that I've counted. So that is how I'll be doing this approach. And the time complexity, as I mentioned, like since we are going to use merge sort operation, so merge sort algorithm, so it will be order of log n. And that was it for this video. Thank you. The problem that we'll be discussing is sort an array according to another. The problem says that we have been given two integer arrays a1 and a2, and the size of the first array is n, the size of the second array is m. We need to sort the first array such that all the relative positions of the elements in the first array are same as the element in the second array. So we have to see the example for better understanding. So let us take the sample example here and understand what we have to do. So basically we have to sort the first array according to the second array. If you will see here, so let us say that the first array is what? 2, 1, then 2, then it is 5, then we have 7, then 1, 9, 3, 6, 8, and 8. if this is the array that I have and the second array that I have is 2, 1, 8 and 3. So what I have to do is I have to sort the first array according to the second array. So first of all, if you see in the second array, so 2 is coming. So which like this is array 1, okay? So in the original array, and this is array 2. So I have to sort array 1 according to array 2. So first of all 2 is coming. So I'll see all the occurrences of 2 in this array 1 and I'll write them. So you can see here and here 2 is occurring. So I'll write it. Then what will happen? I'll consider the occurrence of 1. So 1 is occurring here, 1 is also occurring here. So 2 occurrences of 1 are there. And after that, I will consider the occurrences of 8. So 8 is occurring here and then 8 is occurring here, right? After this part, we can observe that 3 is there. So 3 is occurring here one time. So I'll write 3. Then you can observe that some elements are left. What elements are left? So elements left are 5, 7, 9 and 6. These elements are not present in the second array. So whichever elements are left, I have to sort them and then put it in the answer. So these elements I'll sort them. So first of all I'll put 5, then I'll put 6, then I'll put 7 and then I'll put 9. Okay. So this is going to be the final answer, and you can see the final answer will be 2, 2, then 1, 1, then 8, 8, then 3 and then 5, 6, 7 and 9. So that is going to be the final answer. So one of the ways of doing it is that I put a pointer I on the second array and I check in the first array that many number of times, like I check if 2 is occurring that many number of times. I put this element 2 that many number of times in the final array. After that I check for the next element, then I check for the next element and I keep on putting them. And whichever elements have not been put, whichever elements are not present in the second array that are present in the first array, I sort, like leftover elements I sort them and then I directly return the answer. But this will take a lot of time and I can do it using a better approach as well. So what I can think of doing is I can think of optimizing this approach, and instead of being brute force, what I can think of is I can think of the hashing approach. So if you see the array that has been given to me, 2, 1, 2 and then 5, then 7, then 1, then 9, then 3, 6, 8 and 8. And if I take the example that is 2, 1, 8 and 3. So first of all I can use the concept of hashing here, and what I can do is I can store all the elements of the first array into a map. So I'll say that map of 2 is equal to what? 2, because 2 is occurring 2 times. Then I'll say that map of 1, like 1 is occurring how many times? 2 times. I'll say okay. Then I'll say that okay, how many times this element 5 is occurring? 5 is occurring 1 time. Then how many times 7 is occurring? So 7 is occurring 1 time as well. Okay. Then how many times 9 is occurring? So 9 is occurring 1 time as well. Then how many times 3 is occurring? 3 is occurring 1 time. Then 6 is occurring how many times? 6 is also occurring 1 time. Then 8 is occurring how many times? 8 is occurring 2 times. So that is how I'll make the frequency array. And once I have made the frequency array, so what I'll do is I'll start my iteration on the second array. I'll start the iteration on the second array, and what I will be doing is I'll simply check if the ith element of the second array is present in the map or not. If the ith element of the second array is present in the map, then whatever its frequency is, that many number of times I'll push it into the answer. So I'll say that 2 and 2. Okay. After this part is done, so I'll erase it from the map as well because I don't need it any further. Then what will happen? I'll come to 1 and like I'll see that 1 is occurring 2 times as well. So I'll insert 1 2 times. After that I come to 8. Before that I'll erase 1, okay, from the map, and then I come to 8. So 8 is occurring 2 times as well. So I'll insert 8. 8 and 8 is inserted. Then 8 will be erased from the map as well. And after that, what will happen? Now 3. So 3 is occurring just 1 time. So I'll write 3. And after that, what is happening is you can see here that the concept is that the elements are 9, 6, 5 and 7. So these elements are just occurring 1 time. And how do I need to sort them? So I need to sort them in ascending order, right? I need to sort them in ascending order. And for this, I can use the normal map, that is the ordered map, which helps me to keep the keys in sorted fashion. So in the map, what will happen? First of all, 5 will be stored. Okay. So 5 will be stored. If I use a ordered map, so 5 is coming 1 time. So I'll write 5. Then I'll write 6. Okay. Then I'll write 7 and then 9. So this will be the final answer. So that is how we'll be implementing this approach. And for doing this approach, since there are total n elements in the first array that I'm inserting, so I'm using an ordered map, so it will take n log n time complexity, and the space complexity for this is going to be order of n because I am inserting elements into the map. So that is what I'm trying to do here. Let us try and write the code for this problem first of all. So suppose that this array has been given to me. So then what I'll do is let's name it as A1, okay, and let's name it as A2, and the size will remain n only. So what I'll be doing first of all here is I'll be saying that I'll have an answer vector. So vector like in answer, and what I will have here is I'll have a map. So I'll say that map of int comma int to store the frequency of the first array elements. So I'll have it as empty. Then I'll say that for int I starts from 0, I is lesser than n, and then I plus plus. So I'll increase the frequency one by one. I'll say that map of a1 of I plus plus. So the frequency is going to increase one by one. After this part is done, so what I will be doing further is I will say that now I need to iterate to the second array. So for int I starts from 0, I is going to be lesser than m, okay, and then I will do an I plus plus. So I'm simply iterating to the second array, and what I will do is I'll say that if map dot find a2 of I, if the ith if the second if ith if second array element is found inside the map. So if it's not equal to map dot end, okay, if it is found inside the map, then what I need to do is I need to say that int frequency, like I'll say that what is the frequency of this element. So frequency will be nothing but map of a2 of I, okay. So this will be the frequency. So I'll store the frequency, and then what I will say is that many number of times I need to insert it into the final answer. So I'll say that while frequency of my frequency minus minus, so I'll decrease the frequency one by one, and that many number of times I am going to push this element a2 of I into the final answer. So I'll say that answer dot push back what a2 of I, right. I'll push this particular element a2 of I, and then once I'm done with this part, so what I'll be doing is like after this part has been inserted, after the elements have been inserted into the final array, so what are the things that I need to do? So after this I will say that I need to erase the current element from the map. So I'll say that map dot erase, I'll say that map dot erase a1 of I. So like basically a2 of I, not a1 of I. So a2 of I, the current element, I'll erase it from the map, and this is what I will keep on doing if I find the element. After this part is done, so I will iterate through the map once again, okay. So I'll say that auto I will say that auto I is to map. Basically I'll iterate through the elements of the map, and then once I'm iterating through the elements of the map, so I'll say that if I'm iterating through the elements of the map, so basically what I need to do, I need to say that I'll store the frequency. The frequency, like basically that means like I dot first stores the element, and I dot second stores the frequency. So I'll say that while I dot second minus minus, so if the I dot second is still prevailing, in that case what I will say is that answer dot push back, I'll push back the current element, that is nothing but I dot first, okay, I dot first into the answer, because the keys will be sorted. So that is how I'll be doing it. And then once this part is done, so I can simply return the answer here. So let us try and compile to see if there is any other error in this code. Okay, so it seems to work here. We are getting the expected sample output. Let's try and submit this code as well. Okay, so you can see that our code was able to pass all the test cases. Now talking about the practice problems here. So the first practice problem that I'm giving is insertion sort. So basically in this you will be given a function and you have to implement the insertion sort here. Next problem is a medium problem, that is nothing but merge sort. So basically you will be given an array, you will be given the starting position, you will be given the ending position, and you have to sort the array using the merge sort algorithm. And the last problem, that is the third problem, will be minimum platforms. And in this problem we have to find the minimum number of platforms such that all the trains we have been given arrival time and departure time, and we have to find the minimum number of platforms that will be taking for doing the task that has been given to us. So you can try this problem out as well. Thank you.